Okay, so in this final video I'm going to show you how to apply polynomial division, maybe where we're not factorising, maybe where we're just applying division even though there might be a remainder. So we'll go through this. One a bit trickier, numerically it ends up being a bit trickier as well. Let's see how we go. So what I'm going to do is I'm going to say that we're actually dividing by the divisor x minus 3. And we'll apply the polynomial division, and then we might actually finish by talking a bit about the remainder theorem. So let's start with the polynomial division. So we've got x minus 3 is dividing this big old cubic here. 5x cubed plus 7x squared minus 10x minus 1. And so we go through that process again. Remember, if I do it up as a little table here, we've got 1, 2, 3 steps each time, starting with the cubic, and then going with the quadratic, and then going with the linear. And I'll show you as we go through which one we're doing. So first I take the cubic divided by x, the leading term in the thing we're dividing by. 5x cubed divided by x is 5x squared. So I get 5x squared there, and that is step 1 for the cubic. Step 2 for the cubic is to get this 5x squared and multiply it by the divisor. 5x squared times x is 5x cubed, as we would expect, and 5x squared times negative 3 is negative 15x squared. That's step 2. And then we do our subtraction. 5x cubed minus 5x cubed is 0x cubed, and 7x squared minus negative 15x squared is plus 22x squared. And that's step 3. We bring some of these values down, doesn't have to be all of them, but I'll bring them all down. And now we're on our quadratic, so we've hit our quadratic now. And we follow the same process again. X into 22x squared is 22x. 22x times this, that's step 1 by the way. 22x times this is 22x squared minus 66x. That's step 2. Step 3 is the subtraction. 22x squared minus 22x squared is 0x squared, and then 10x minus negative 66x is like plus 66x, so we get plus 56x, and that's step 3. Bring this negative 1 down. Now we go into a linear. So how many x's in 56x? Plus 56. 56 times this, so that's step 1 done. 56 times this is 56x, as we'd expect. 56 times negative 3 is negative 168. That's step 2, and step 3 is to do our final subtraction. Negative 1 minus negative 168 is 167. So our answer is remainder 167. And that's our remainder that we've got there. So magic, and you can see here that we're just following that 3-step process and repeating until we get down to our lowest possible term. Easy as. It's very procedural. Just follow that procedure. So let's just quickly clean up this procedure though and talk about the remainder theorem. Before I do that, I might actually write down my final answer here. We'll do it in orange, and that is that P of x is equal to x minus 3, it's my d of x, times q of x, which is 5x squared plus 22x plus 56, and then plus that remainder, r of x. Now of course we've just been asked to divide, and that's our final, when that's divided, what's happening. Okay, this might be the final answer. We're not really being asked to factorise that, so I'm not looking at that, but maybe a question will ask you to fully factorise or something, so just be wary of that. Okay, now our remainder theorem in pink. Our remainder theorem states that if you substitute any number into here, so we'll call it alpha, and you don't get 0, remember 0 means there's a remainder of 0 and it's a factor. Well, if you get another number, that will be your remainder. So we're going to test it now for 3. So we're going to say r of alpha is equal to your remainder when that division happens. So after division by x minus alpha, okay? And here we're going to do r of 3. So r of 3 is equal to 5 times 3 cubed plus 7 times 3 squared minus 10 times 3 minus 1. 3 cubed is 27, so this is 135. 3 squared is 9, so this is plus 63. Minus 30 minus 1. And this of course is 198 of this of course, yep, good one. And minus 31, and this is 167. Obviously you probably have a calculator or something, but you can see what's happened here is we've actually now got a remainder there which matches the remainder we got here through our calculation. So, happy days then. So now just to round this off, a quick discussion. We're dividing a cubic by a linear. You might be asked to do a quartic or a quintic. Okay, it says small powers. We don't really know how far that will go. I think a quartic's probably the biggest you'd ever get asked. But d of x as well is linear. There's no reason why d of x couldn't be a quadratic, for example. Or even if we're talking about a quartic, couldn't be a cubic. So just be aware, you can do this division. There's examples and a range of examples around. Have a read of them. It's less likely, but it's a possibility. So definitely have a look at that. Okay, I hope you've had the time of your life.